Live already.
Okay, finally.
Mhm.
Okay, so I'm not quite done with the first one,
All right.
but did you get pi halves for the level set?
Yep.
Uh, So you get for the answer.
Um, for the answer, I got the level set pi halves equals sine inverse y minus sine inverse x.
Okay, that's what I got too.
All right.
Okay, let's go to the next one.
Alrighty.
Did we do this week?
I mean,
Doesn't look familiar.
no. Show that the volume of the segment cut from the paraboloid by the plane equals half the segment's base times its altitude.
Eh, How paraboloid? Which one is a paraboloid? How would that have a volume? Isn't a paraboloid like?
Yeah, so what I'm picturing is just a bowl that starts at the origin. Um, if you make z like a number, then that would be like its radius squared. So each cross section going up is are a bunch of circles or ellipses if they're different values for a and b. So
Okay, so the
just
volume would
a cross
be
section of
like,
ellipses, like, but it's like they open up
okay,
parabolically. So that's how I think of
okay.
it.
Well then,
I don't know. um, I guess, yeah, maybe.
you did like a cross section and then use an integral to
Yeah.
compensate for the curve.
So it would be um like it'd be kind of the area of each ellipse integrated by the value of
Yeah.
this size, integrated by the x and y values.
Okay.
Yeah. Okay.
So I think those are the right numbers.
Hmm.
So mm, so the area of the ellipse. Oh wait, I do remember doing this now. The area of the ellipse is like pi AB, right?
Yeah.
And then, oh, I do remember doing this one, and it was really tricky. I write it down though. It is. Oh, but it was like an ellipsoid on one we did. There was this see. Maybe it didn't use an integral actually.
You can use if you have the area of an ellipse in terms of A and B, you can use those as constants. I don't know.
I think oh, here we go. I have something written down that says the integral from negative k to k pi ab k for the integral. I think k is h.
Okay. Okay.
From negative h to positive h.
I'm not sure.
Equals h half the segments. Oh, maybe that's not right. I have it here going from 0 to k. So 0 to h, pi ab. And then where does the h over c come from? Why would you do that? It's like z over c, I guess,
Mm-hmm.
equals. Well, but why would you multiply the area by what it be times, is that the height?
Yeah. So it would be okay, so thinking about this integral, it would be like length times width times height for the volume, but the length
Right.
times the width is the area of the ellipse, and the height is just the height. So
It's
since
just
it's
8.
changing values for AB, like pi AB, it would be the integral, like using like the height, but it's just like it's little slivers of the height. So it would be the differential of z. So
Okay.
we just have to find dz in this sense, if that makes sense.
Yeah.
So
Well, or find dz or take the integral of dz
um,
slices.
so what I'm picturing is um, like okay, this can be wrong, but that's what I'm picturing. So
Integral of the area and cross sections. That totally makes sense. Yeah.
I just don't know how to do that algebraically. But I think that's how you set up the integral.
Yeah.
I'm gonna try looking it up.
I think he mixed two problems together from the homework. One that was,
Yeah,
and that one you were supposed to show that the area could also be written as 3 pi a.
yeah, I'm
Other
remembering this.
one, we would do the integral of a paraboloid.
Mm-hmm.
So I think he mixed the two of them together.
Hmm.
Oh wait, here it is. Okay. Okay, I'm gonna share my screen with you because I think I have.
All right. Yeah.
So I guess I did do this exact problem. I just don't remember it being like this, but
Well,
express the area of the cross section cut from the paraboloid, which that's the same equation as the one we just did, by the plane z equals k, so it's just k instead of here even.
okay. So
And then,
so
so first it says the area is pi ab times k over c.
hmm.
Pi, where the k over c comes from. Supposedly the area of one cross section, but why? Do you have to
Well,
factor in k over c because the ellipse is affected by the parabola?
yeah. That's so I'm thinking about it as like, okay, think of it as like a level set. Um, at when you have your height and you have your C value, um, that's that is the like that affects both the a squared and the b squared. If
Makes
that makes
sense. So they're
okay.
like a
So
function of.
okay, um, anything under the x squared would be a squared times c over k, and anything under the y squared would be b squared times c over k, and all that equals 1. Okay.
Okay.
Yeah.
Yeah,
And
yeah.
so when you solve for the major axis length, which is the square root of anything under x, it would be square root of a squared times c over k equals
Ah,
a root c over k. And then the minor axis length would be b squared times c over k was b roots c over k. And so the area is pi times the major axis times the minor axis, or pi. It would usually be pi ab, but now it's pi times a root c over k times b root c over k, which is pi a b c over k. Is it k over c? K over c.
how does
It's
it
k over
become
c.
K over C?
That's because I did it wrong. My bad. It's supposed to be k over c the whole time.
That makes sense.
So that's where they got the K over C.
Okay. So then, sense. So then for the next part, use slices perpendicular to the z-axis to find the volume of the segment of the paraboloid. Pi b, the integral of that. The h is your like variable, so it becomes h squared over 2, and then everything else are just constants, so they stay the same.
Right. And so the only thing you do is h squared. That makes sense.
Okay, and then
Integrate it partially,
see. Okay, then this one not understand, I think, how they were saying. I just knew which one was right, but segment base times the altitude. Oh, okay, actually, I do understand what it's saying.
Okay. So the
Yeah,
segment
does
base
that
is
make
the area we got in the first place, so that's the base. And
yeah.
you have 1/2 and a height, so
There
alrighty.
we go.
Huh. I would have never got that by myself.
I I wouldn't have got it without going back and looking at my work, which you'd think if I did it one time, I could do it a second time, but nope. Okay.
Yeah, I guess I'm sort of remembering this, but I kind of completely forgot about that problem.
Funny, funny.
If
Okay.
you follow the math
Should we go to
line,
the next one then?
it guides you through it, and then
Yeah, yeah. Okay, should we do number 3?
we should. Solve the initial value problem as for r as a vector function of t. So it gives you dr dt, and it tells you to find r of t. And the only trick is that it's a vector value function.
It gives you the initial value, so you have to like
Do it from
your C, your
right.
plus. Okay.
I'm just gonna rewrite it into component form. It's always been easier for me to do.
Me too. I cannot look at it with the extra IJ and K. It just makes it hard to see what you're looking at.
Yeah, and it's kind of cooler in a sense. Like it kind of shows you, like, oh, these are like coefficients of this thing, and I totally understand
Yeah,
it. It's
theoretically,
kind of
yeah.
messy. The the angle brackets or whatever are easier to see.
Yeah.
So oh, I was about to say, it's funny how they chose a constant to be k when there's a k vector. I think that means this because it's a 1 in the k direction. So the
Oh.
the
Oh yeah.
r
The
of
R of
0
0.
is just 0, 0, 1. 0
I'm
i plus
glad
0,
you
0 plus 1
mentioned that
pi.
because I was looking at it as if it was like,
Right. I looked at it too. I was like, wait, shouldn't that be a vector? Oh, wait a minute. Those sneaky people. It is a vector. Oh, yeah.
did you for just for like the integral of all of them first, those.
I have. I'm just starting them. I'm almost done though, is the thing. So,
Okay.
ooh, t plus 1 times b2, 3 halves. Okay. For x, did you get t plus 1 to the 3 halves minus 1? Okay. Go on to y. And y equals e to the negative first times t. And
Just
z, bt over t plus 1, and then plus 1, so cz, and
-1 on z.
I got c is 1. Doesn't make sense. ln of
Oh,
1
yep.
is 1,
Yep.
right? Yeah.
C is 1.
Yeah.
Okay. So,
Mhm.
so then it's ln of t plus 1 plus 1.
Yeah. So our t equals t plus 1, 3 halves minus 1, t e first ln t plus 1 plus 1.
That is what I got.
Already.
Okay.
And I wrote it pretty on the bottom. Oh, glare.
Cool.
Sweet.
Okay. Awesome.
Woohoo.
Okay, so that's all those problems. Let's go to quiz corrections.
All right.
I'm gonna pull up my quiz. 6? Oh no, quiz 5, right? Yeah. 6
Yeah.
back yet.
Quiz 5. Here we go.
I missed a couple on this one. Okay, first of all, number 1, B, last semester too, and so did everyone in my group, and I still cannot figure out B. Did you get 1B right?
Yeah.
What did you do?
They're just like shading in inequalities, right? And so you like draw like coordinate thing, whatever.
Uh-huh.
You draw the coordinate plane, and then you draw the angle pi over 6, like
Uh-huh.
that. And you also go into the negative direction because the radius could be negative. Oops, I kind of curved it a little bit. And then you do the
Negative
same thing
pi
for negative pi over
thirds.
3. They're actually perpendicular.
Wait,
and it's
why
got
do
to
you
be.
go in the negative direction as well?
So what? Yeah, that's
As well.
because they didn't bound R. So R is true. So the domain of R is true for all values, positive and negative. R is all real numbers, so it's between negative
Hey,
infinity and infinity.
I
So,
never would have come up with that.
yeah, I only came up with that because I noticed the other questions how it was like they had bounds for R, but this one didn't. So I thought of what all values R were.
Wow, that is really clever. Great job.
Oh, thank you. So that's what I got.
And oh, okay.
Yeah, the one that kind of forced me to think about that was D and a little bit C,
Right.
because D was like
Okay.
it had bounds for R, so it's kind of like this weird hourglass that's like bigger on one side than the other. So the other one, I just figured, hey, it's got the full hourglass. Yeah,
Wow, thank you so much.
yeah, and I got like a 75 on this thing, so I kind of missed a couple as well.
Um, I miss. Oh, I missed number 5. Did you get that one right?
Five, I got quarter. I got only a quarter of the points. No, I don't think I did any of that right.
All right. Okay. That one later then. What problems do you want to look at from it?
So I missed some points on looks like 1, 2, 3, 4. Why is that 4 or 7? Hmm. I missed some points on 3 of the problems. Two of those like two of the 3 parts of number 2. So 2A and 2C I missed points on. The first one I got 4 out of 7, then on C I got 0 out of 7. So whatever I did wrong, I
Okay.
think I might need help on that. Even though I thought
Let me
it was clever.
share my screen again. Let's try this. So here's 2A. Used the formula that like tangent theta equals y over x, and so then you just plug in theta. Did you do that part?
Yeah.
So then you just solve for y. So you just put x over on this side.
Whoops. Yeah, I solved for Y, but I didn't ever evaluate tan pi over 6. That's probably where I went wrong. I could have
You
written
just say y equals 10 pi over 6.
times X. Yeah. So that's probably why they docked me 3 points. I got a
Ah,
4 out of 7, so
well,
that's where I went wrong.
technically that's still correct. It's just a
Right.
different
One
would
time,
argue it personally.
one time last semester I took physics, like, and there was an online part, like all the homework was online, and it asked me to find the square root of 33.3. So I was like, I am so done with this right now. I don't want to be doing homework. Like it was a Friday and I was watching a movie during it. I was just not doing it. I just didn't want to do it. So I literally typed in the square root of 33.3 and it was like, correct. It's like, oh my
That's
God. Like, you
awesome.
wanted me to evaluate it, not type in the square root of 33.3. But it took it.
That's
So,
hilarious.
but yeah. And so I actually didn't get any points on 2C. So
Okay. Um,
no.
let's see what I'll given on
Oh,
this one.
dang it. I know I went wrong with that one too. Okay, so what I got was Um, 2 cosine theta when it should have been 4 sine theta because I'm just an
Okay.
idiot. I did the whole thing right, except I I put I didn't FOIL y minus 2 right, so I got like y squared minus 2y plus 4, and that's
Oh,
wrong. And then
dang.
I also substituted y for r cosine theta when it should have been r sine theta. So I know where I went wrong, and I
Okay.
also kind of did some weird things. Okay, so I'm good. I'm good there.
Thanks.
Yeah. And the only other things that I missed on this test were 3B and 5.
3B. I got 9 for the answer right here.
So what was the integral that you used? Like, how did you set it up?
I did like 2 integrals. I did the integral of theta squared minus the integral of 1.
Okay.
Just the thing is the integral of theta squared minus 1, but just separated them. And then for the bounds, I did from 1 to 4.
All right. I'm trying to look what I did. Oh wait. Yeah,
I guess you
never mind.
multiply it by half
It
as
has you
well.
set up the integral in the first part. Okay, my bad. Cool. I
Oh,
set up
yeah,
the
yeah.
integral
So you're just
correct.
solving the integral from part A?
Yeah. Okay, so 1/3 theta cubed minus theta from 1 to 4 all over 2. 6 theta cubed. Okay, so 4 cubed over minus 1 cubed 6. Hmm.
How did I? Okay, this is 4 cubed over 6. That's where this 32 over 3 comes from.
Oh, 32 over 3. I thought that was 3 cubed. And it's like, wait, it's 4 cubed. No, but
Yeah, that's
3
what I
squared.
thought it
Oh
was
no.
at first as well. Yeah.
Yeah, I think we're just getting a little dyslexic. That 32 over 3. Okay. So, uh, minus 4. 4 halves minus 1. Okay. 32 thirds. Okay. That is. Oh, okay. So I see where I went wrong. Yeah. I got up to that point and then I did something weird with the second term. Oh, I never even integrated the second term. How about that? Okay.
Uh,
So, yeah, gotcha.
okay.
So I'm good on that.
Okay. Um, should we try working through 5 together and see if we can figure out where we both messed up?
Yeah.
Okay, so
So
first of all, let's see if we got the same thing for the integral. So this is my integral. The length equals the integral from 0 to pi square roots of 2. And the square root of 1 plus sine 2 theta cosine squared 2 theta over 1 plus sine 2 theta.
that is not what I got, but that is much more nice looking than what I got.
Okay.
So 1 plus 2, 10.
Yeah, because
1 plus
r is
sine 2
right here
theta.
and then it's r squared. Sure.
They go at 11:40.
Where?
Okay.
Okay. I think I did the integral
Actually,
right.
I got 1 plus sine 2 theta plus 4 cosine 2 theta
4 cosine 2 theta?
1 plus sine 2 theta.
Oh,
Very much confused with myself.
okay, what did you get for DRD theta?
I'm just gonna do that. Screen share. There we go.
Okay, cool.
Okay, so are you seeing my screen?
Yep.
So this is what I had for R, which I think is right. So it's square root of 1 plus sine 2 theta. So R prime would be derivative of R with respect to theta, which is using chain rule, the derivative of 1 plus sine 2 theta, cosine 2 cosine 2 theta times square root of, that should be over, okay.
Two.
Yeah, you did it right. Okay. That should be cosine 2 theta over square root of 1 plus sine 2 theta. So you had that right. I just did that wrong. I forgot to drop the power.
Oh, okay, that makes sense.
I didn't take the derivative of the square root. So the 2 would have went away and this would have been on the bottom. So then plugging it in would be then 1 plus sine 2 theta plus cosine 2 theta over square root of 1. Oh, okay. Cosine squared 2 theta.
Right, so I just got rid of the square root on the bottom and then I made it cosine squared on top.
Alrighty.
And then when I started to solve the integral, I multiplied by 1 plus sine 2 theta.
Right.
So like this piece over here, I multiplied by 1 plus sine 2 theta. So then you have 1 plus sine 2 theta all squared plus cosine squared. And maybe that is where I messed up.
That should be fine.
No, wait.
Because if you
Squared plus 2 sine 2 theta plus
if you
sine
take the
squared 2 theta plus cosine squared 2 theta. Yeah.
so it would be 1 plus sine squared theta plus cosine squared, or 1 plus sine squared 2 theta plus cosine squared 2 theta. That should just be 1 plus 1, right?
Right. I have the 1 out on this side.
Right.
Do sine 2 theta in the middle, right? When you FOIL that, you get 1 plus sine 2 theta plus sine 2 theta plus sine squared 2 theta.
Yeah, you're right. So it's 2 sine 2 theta. Yeah, this is all looking good. And
Okay, so 2 sine 2 theta plus 2 We factored out this 2 to correct, right?
Yeah, that's
2.
great. So
So then you cancel the 1 plus sine 2 theta, and it's just the integral of 2 times 2 theta.
yeah,
And I got it wrong.
yeah,
I guess maybe
that looks all
I
right.
could have had my bounds wrong given.
Yeah, pi root 2 and 0. So as far as I can tell, you got it all right. Like mine's just ugly. So
To ask them, I guess,
yeah,
what I did
so
wrong.
it looks like you got it right.
Okay. All right. Well, and you know where you made your mistakes now, so.
Yeah.
Okay. Well, I think that's everything then. I don't have any questions from the homework for this week, at least not yet.
Yeah. So me neither. I mean, it took me a while to do some of the stuff this week just because it's new.
Yeah,
It was
this
just
week definitely
tedious.
took longer.
They had some pretty tricky questions.
Definitely. I hate like some of the problems they give us. I'm like, you could teach us this concept without giving us such a mess.
Right. Like they at least like start us off walking in the kiddie pool or something. Um, I don't know. The thing that that took me such a long time was you find the tangent plane. Um, I think it was
Oh,
to like a function that was in like r and theta or theta and z, and it never
yeah.
explained it, and it had no help me solve this part, but they had like suggestions when you got it wrong.
Yeah,
Like, and
sometimes I'll get
so
it wrong on purpose just to get those little suggestions afterwards.
right, and it took me the longest time. Like the form ax plus bz plus cy equals d, where d equals a times little a, all that stuff. It would have been so much more helpful if they just gave us the formula for a normal vector and said a, b, and c were like the x, y, and z components of the normal vector. That makes sense to me.
Yeah,
But like the
absolutely.
way
On
they've
that
written it,
one,
like I never understand
like
it.
it only had like 2 questions in that set, and so I went to the next question, and that one had some like help me solve this, view an example. So I like figured out how to do it
Oh,
on that one, and then went back and did the first one.
smart, smart.
Yeah,
And the chain rule is like all the partial derivative stuff. That's kind of fascinating, like conceptually, and is easy to do. You know,
I haven't done the chain rule one yet. I was scared of it, so I did the other one.
the chain rule one, as long as you like, you can as long as you look at the formula and kind of understand what it means. Like it's not conceptually very hard. It's just you got to plug it in right. It's
Okay.
just like you do each component, like you do chain rule from each component and then add them all together. That's all you do. But I will warn you, it is kind of ridiculous numbers. Like there's a lot of work behind it just because of what they gave you.
Oh,
There's a lot easier
dang.
stuff to do, but the chain rule, like they have like really complicated component functions, and it's like what even? But it's pretty simple to do. So
I hope so.
yeah. Hmm.
Okay, well. Um, I guess that's everything.
Yeah. Yeah, we've gone over everything.
And considering that we really started like a half hour later than we meant to, and we're only ending like 15 minutes later than normal, that's pretty good.
Yeah. Yeah. I feel it.
Okay, cool.
Yeah.
All right. See you
Cool.
next week.
See ya.